Now, for the first derivative of the function s prime of t, that will be the velocity function. The first derivative of the position function is equal to the velocity function, and this is equal to the limit when t approaches 0, when h approaches 0. You will calculate this using limits. Today I will not explain to you what is the meaning of this. This is a derivative. The only thing that you have to identify as the limit is the derivative. Is the same thing as the velocity. The limit when h approaches 0 of the s of t plus h function minus s of t over h, meaning that you have to obtain the s of t plus h function, and this will be equal to negative 4.9 t plus h at square plus 7 times t plus h plus 35. Okay, this is the value, the definition for the function s of t plus h. Now, because the derivative is a limit, you will apply this sequence here. You have identified what is the algebraic value of s of t plus h, and you will obtain the limit when h approaches 0 of all of this function here that I will define with using this blue marker of negative 4.9 t plus h at square plus 7 times t plus h plus 35 minus the whole definition of the original s of t of negative 4.9 t at square plus 7t plus 35. All of this is divided by the value of h. So the objective here is to take out the value of h, and the only way to do that is to develop the equation and to define this in the following way. Negative 4.9 times the solution of the binomial at square, t at square plus 2th plus h at square, plus 7 times t plus h plus 35, and here you will change the signs, plus 4.9t at square minus 7t minus 35, and all of this is divided by h. If you now multiply this value times each of the terms that are inside the function, you will have the limit when h approaches 0 of negative 4.9t at square minus 9.8 t times h minus 4.9 h at square plus 7t plus 7h plus 35 plus 4.9t at square minus 7t minus 35, and you are dividing all of this expression by h. If you want to simplify the expression, you will see that the values of some variables here, some terms in the expression will be eliminated, because if you see 4.9t at square plus negative plus 4.9t at square positive are gone. Now also the negative t, 7t, it's gone using the positive 7t, and negative 35 is gone using the 35. So you have here negative 9.8 t times h minus 4.9 h at square plus 7t h, and you are dividing this all by h. Now here you can take a common factor, take out a common factor of h, and the definition of the limit when x approaches 0 will be the h times negative 0.8t minus 4.9h plus 7, and all of this is divided by h. H over h gives you 1, and you have reached the important part of the procedure, because now without this h in the denominator, you can substitute all the h values that are left on the equation by 0. And you will see that at last you will have the negative 9.8 value times t plus 7. And this one is the derivative of the position function derivative. And the way to express that derivative in mathematical notation is one of those ways is s prime of t, and the derivative of the position function is the velocity function. So you have found the velocity function. The velocity function will be v of t is equal to negative 9.8t plus 7.